So the first thing we're going to do is come into the IND360 downloads page on mt.com. This is a very useful page that gives you data sheets, brochures, drawings, manuals, but what's of interest to us today are our PLC device description files. So this is where you can find the EDS and custom AOP files, along with our sample code. Just note that the sample code is broken down by scale type and application. So today we are running the analog scale type with no application, so just the base version of IND360. So we would select this file right here for Ethernet IP, download that, which we've already done, and then use that for our system. The next thing we want to do is come into the web server of IND360. So in this web server, we have a lot of options, but again, we want to focus on what's important to us today. We're going to come to the industrial Ethernet settings. In our dropdown, we want to make sure we have Ethernet IP selected. We want to select how much data we want out of this system, whether that's 2 blocks of data, 8 blocks of data, it does not matter. We just need to match this in the PLC settings when we add the IND360 to our project. Otherwise, we want to make sure that we set the IP address for the industrial Ethernet port, the subnet mask as well. And then we have an option for this supervision. If we disable this, this means it is no longer an error if our IND360 is not communicating cyclically to a PLC. But again, the point of this video today is to connect it to a PLC, so we will leave this enabled. Make sure after we change this that we select set for those changes to be written to the IND360. So next what I'm going to do is I'm going to come over into a blank Studio 5000 project. The only thing that I've added here is the settings for our controller. You can see we have no additional devices connected here. And what I want to make sure is that I have either the EDS or the AOP for the IND360 already installed on my system. If you do not, you can of course come down to the EDS hardware installation tool or install the AOP separately. But I know that this is already the case for my system, that it is installed. So I will just add a new module here under the industrial Ethernet. I can search for IND360 and I can double click to add that to my project. So again, I need to give it a name. I'm just going to simply call it IND360, and I will use the IP address that we had previously set in the web server. It is also the default IP address for the industrial Ethernet ports of 192.168.0.2. So again, what I want to make sure here is that I look at the field bus format. Remember I said we had to match the 2 block or the 8 block. Again, if I look here in my web server, we're using the 8 block format, so I need to make sure that that matches exactly. So now we can see we have some controller tags for the IND360. We have our measuring block and our status block. So I can go ahead and expand our measuring block, and we can see we get all this nicely labeled data just from having that EDS or that AOP installed. So what I'm going to do is I'm going to download this and go online with my controller, and we'll see what kind of data we get out of this. Alright, so immediately we can see we have our heartbeat bit toggling on and off every second to let us know our connection is active. And we can look in our measuring value. By default, it's going to report gross weight. So we can see that as I add weight to our scale, that we get new weight values in the measuring value. So again, I can remove those weights, and we can see that changes here as well. So we are connected to the IND360, we are getting data from it, but this maybe is still a little bit further away than you'd want from what you want to be doing in your system. So let's start to look at what it might take to incorporate our sample PLC code and pull in some add-on instructions into our new project here. So I'm going to go offline. I'm going to open up the IND360 sample code. Again, is available on that downloads page on mt.com where we started. And what I'm going to do is I'm going to right click on this top rung because this weight processing block is going to accomplish most of what I want to do. So I'm actually just going to import this one rung in. So So I would export this rung, which I have already done, and then we will come over to our new project. We can open up our main routine, and we can see we have nothing in our ladder logic. I am simply going to import the rung, and we can see I have this rung available here that I previously exported. I can select which language I want to use. Here it'll be English, and I'm just going to say OK to everything here. Go ahead and delete that unused rung. So now we can see that is pulled in from our other sample code project into our new project. So this is great, obviously, if you already have an existing PLC project, you don't need to start from our sample code as the basis. Obviously, you can import as needed. And what I'm going to do is I'm going to simply then download and try to go online with this and see where this gets me. All right, so let's go ahead and transition our view here to look at our scale as well as our local IND360 display. So we can see that display and compare it to our real-time weight and our stable weight here in the add-on instruction. So as I add weight to the scale, we can see it changes locally as well as inside the PLC. You'll also notice the stable weight waits a second to update until it detects no motion on the scale, whereas that real-time weight is constantly updating for us. We can also send commands via the PLC. So for example here, if I want to tear the scale, I can simply set the tear stable command to 1. We can see that was done. And in our local display, it's set to 0. In our PLC, it still says 2. That's because we have not asked it to change from gross weight to net weight. There is a method to do this, which I can show here momentarily, but again, we can show what happens as we remove weights there. So now if I clear the tear, I simply set the clear tear command to 1, and we can see our local display has gone back to match our PLC display. So the reason it did not display the tear weight or the net weight previously is because we have this wait command parameter here. This tells us that after whatever commands we input, what wait command do we want the IND360 to return to reporting in the PLC. So a command of 0 means I always want to report gross weight in this block. A command of 3 means I always want to report net weight. So now if we tear our scale, we can see our weight has dropped to 0, which matches the net weight we see on the local display. So if you ever see that issue where the PLC is not reporting the correct weight you think it should be reporting, that's a common mistake that we can see that you maybe want to correct and actually request the net weight be reported. So now once again, if I come up here and I clear the tear, we can see we have gone back to the gross weight mode. We also have indications that our net mode is 0, so we do not have a tear that has been taken. And we can also monitor this motion bit. So as I fluctuate the weight on the scale, we can see that motion bit is high and it only drops to 0 when the motion condition is not present. So again, very simple block. We can open this up and we can look at the logic of it. So if you want to understand exactly how this works so you can customize and modify it for your own purposes, please do. That is what it is there for. But it is just that simple to get an IND360 integrated with an Ethernet IP system.